Hey everybody, this is Coach Hammock coming to you from beautiful Georgetown, Texas, here in room 122 at Benold. Hoping you're having a great day, bringing you your first ever flipped classroom lesson. Today we are going to be putting the fun back in functions. Alright, so let's just jump right in. Alright, so first thing, we need some vocabulary just so that we're speaking the same language here. A function, that's what we're talking about all today. And basically, a function consists of a domain and range, and this is the key part of this, a domain and a range, and it has a pairing of inputs with outputs so that each input only has one output. And I promise that will make more sense here in just a little bit. But we need to talk about what are our inputs and what are our outputs. Well, the first thing we're going to talk about is our domain. And the domain is the input. It's also called the independent variable. Alright, and the way I remember this is you have to be very independent to let your parents go, or to have your parents let you go to the domain by yourself. So, independent, input, domain. The range is going to be your output, and if this one's independent, then the range has to be your dependent variable. Alright guys? There we go. Alright, so our domain is our independent, our range is our dependent. Moving on. Independent, dependent, just right again. Independent is going to be our domain, and our dependent is our range. Alright, so we're going to identify the domain and range of a function. When you look at this, you've got an input and your output. Well, we already said that the domain was our input, so I'm just going to put a little D right there. And the range is our output. Now, when you're looking at a table and it gives you specific values, you need to say that the domain is each one of those values. Because at 0 hours, the temperature of this thing was 24 degrees Celsius. So our domain is going to be 4 values straight across: 0, 2, 4, and 6. And our range is going to be 24, 27, 30, and 33. Pretty easy right there. Remember, range, output, domain, input. Alright, right here. I'll let you check that real quick. Okay, so these were the examples or the answers I came up with. The domain is our input values. Our range is our output values right there. And remember, you just have to list them out on that. Later on, we'll have different ranges and things like that. But for right now, just give this certain values. Okay? Now, this is a really cool way of looking at this. When you look at it in a table, you can see it a lot better. So right here, we're going to say if it's a range or if it's a function. And remember, one input has to equal one output. And it's kind of confusing here in a second, but let's look. 4 gives me 1, 8 gives me 2, 2 gives me 3. Each input gives me one output. This is a range, or is a function. Alright, now, when we look over here, this gets kind of tricky here. We have a 2 that gives me a 2. But wait, we have a 2 that also gives me a 4. So we have the same input, but it's giving us 2 different outputs. That makes it not a function. And it's really easy to see on a graph, and we'll get to that here in a second just to give you a little teaser on this. If you're looking at an XY table, or an XY graph, and you can go over 2 and up 2 and over 2 and up 4, if there's ever a point directly under another point, so like if it's raining right here and the top one gets wet and this one doesn't because it's getting hit by that one, it's not a function. It's got to be clear all the way through. All right, so I'll let you answer these real quick. Okay, so this is what I got. I got the top one not being a function because this 5 gives me a 3, but this 5 also gives me a 4. If you ever have to cross numbers like that, it's not going to work because I could say that this 5 gave me a 4, this 5 gave me that 3. So that's not going to be a function. This one over here is because each input gives an output, exactly one output. All right, so wow, this is taking what we just did and making an equation and then filling out a table. The output, I'm just going to say y. Y is usually going to be our output, is 2 less than the input. So it's going to be our input of x minus 2. All right, so let's look. Input, I'm going to go ahead and put an x next to that, and the output, I'm going to put a y. So if I put a 2 into that equation right there and go 2 minus 2, that's going to give me 0. If I put a 4 in, 4 minus 2 gives me 2, 4, 6, 8, right there. So looking at this, this looks like a function to me because I can tell you that's a function right there. Why? Because each input is going to give me exactly one output. There's never going to be a, like for this 2, I'm not going to have a 0 and a 6 or anything like that. So the domain of this function, of the function y equals 3x, is 0, 1, 2, and 3. All right, start getting into the habit. When you've got worked, when you can do it, highlight it right like that. 0, 1, 2, and 3. So I'm going to go here, and remember, x is our input, and it's also called our domain. This y is going to be our output, right like that. So my domains are 0, 1, 2, and 3. Now when I put that 0 into the x value, 3 times 0 is 0. Put the 1 in, answer is going to be 3. I put the 2 in, 3 times 2 is 6. And then I put the 3 in, 3 times 3 is 9. So the range of this function is 0, 3, 6, 9. Now, even though the 0 input has a 0 output, that's fine because it only has one number as the output. Okay, so let's write a rule for this. All right, so we're going to let x be the input and y is the output. Notice that each output is how much more? Well, I always like to tell my class, if you're stuck, what you can do is you can draw alligator teeth on it right there and look at the change. This is plus 4, plus 4, plus 4, plus 4. So there's a common increase of it. Look at the input. How much did those things go up by? Well, it looks like it's plus 2 each time. So what I can do is I can take this and put it over that. So if I went 4 over 2, that's going to equal 2. Okay? So notice that each output is twice the corresponding input. So a rule for this function is going to be y equals 2x. See, I got that 2 right there. And we're going to talk about slope later on, but that's basically how you find slope of these, is you put the rise over the run. Okay? So it's going to be 2x. So this is a function. Each input gives a different output. All right, so figure out the rule for this one and pause it and then press play again. All right, hopefully you went through, drew your alligator teeth if you were stuck and saw that it was a 1.5 increase each time. And so it's going to be y equals 1.5 times x right there. All right, excellent. Okay, function machines. These are pretty cool. All right, a set of numbers called inputs. And you should also be thinking, okay, what's other names for it? You could have independent. You could have domain. Any of those. Those are all interchangeable right there. Or with a corresponding numbers called the outputs. Dependent variable. Or the range. Okay? Alright, so each what must have exactly one output. Is it input or is it output? It's input. Each input has to have exactly one value. So, mapping. There's a lot of different ways. You can see words, tables, equations, graphs, and mapping. Words, 8 less than x. Okay, we can do that. That's just y equals x minus 8. So if we were to put that into a table, you like input? No, it's input. Input x, output y. It doesn't matter what values we put in for x. It's still going to be, our output is going to be 8 less than x. So if I put 0 right there for an input, my output would be negative 8. If I put 100 there, my output hopefully would be 92. Okay. Now, mapping diagram. This one's pretty cool. You just list your inputs right here, and then you put an arrow over to your outputs. And the cool thing about this is it's very visual, and it lets you see, okay, 15 goes here. If there was another output that was 15, it would have another arrow going that way, and then it wouldn't be a function because it can only have one output. Alright, so let's determine if these are, if the following pairings are functions. We have 1, 2, 3, 4. Okay, we have all these. We have an output of 0 for 1. That's good. 2 has a 1. That's good. Now, this is going to be crazy, but I want you to watch. 3 gives me 2. That's okay. 4 gives me 2. That's fine. You can have multiple inputs equal the same output. What you can't have, this is a function. Alright, now let's look over here. You can't have this. See how this 0 gives me a 2 and a 3? That doesn't work. That is not a function. Alright? So, that's a good indicator. That's a great example of what a function is not. If we see an input value that gives you two different output values, that can't work. Alright, that's the difference between these two. And that's a hard concept, and I really want you, if you have to rewind it and watch that again, do it, because I want to make sure that y'all understand that. Okay, looking over here at this example, right there, right there, right there, that looks good to me. This is a function. Alright, down here, you have x and y coordinates. And basically, all algebra is from here on out is lots of graphing on the XY axis. We're going to be graphing pretty much every day. So anyway, if you look right here, X is your input, Y is your output. I see a problem right there. Okay? Alright. So we're going to talk more about these later on in class, but hopefully that gives you an idea of what functions are and what they aren't. Make sure you took good notes over this. We're going to talk about it in class, and I hope that you have a great day, and I'll see you in class. Talk to y'all later.